Hello, students of any physics class taking grade 12 physics. I'm just going to go through some energy questions, good for practice, also good for your exams, any energy unit chapter test that you might have. So I'm just going to quickly go through how I answer these questions, what methods I use, how to approach these questions, and the solutions to these questions as well. So I'll probably make a series of videos, considering that it might be a little lengthy to cover it all in one video. So hope you stay watching in this video and you will learn how to solve some energy questions that may appear in your grade 12 chapter/unit test. All right, so let's get started. So we can see here we have the question 24. How much work is done to speed up a 2,200 kilogram car from 12 meters per second to 24 meters per second? So as we know, so I will start writing the question here. Let me try using a grid, might help. So with question 24, we know that we can quantify work and energy that are basically used as the same term arbitrarily, right? We know we can consider kinetic energy in this equation, considering that they are going from a set speed to another speed with a given mass, right? So we know that energy can be expressed as half mv squared. This is the tool that we necessarily have that we can use in our question. We are looking for the change in work. So if we are looking for the change in work, we know we are approaching it from at E final to E initial state, right? So if we're going from this state, we can rewrite the equation as half mv squared F minus half mv squared initial. And if you know, you can factor the VF minus VI from the equation. So, or we can factor the other way around, sorry, half M VF square minus VI square. Remember that you can't pull these two outside the bracket because that's violating math laws. A lot of people forget that that's not a thing. You're not allowed to take the square and factor the square outside the bracket. That'll give you a completely different value. So we see here, for this example, we have half 2,200 kilogram, and in another bracket, 24 meters per second square. Consider the square minus 12 meters per second square as well. Right? And if we have that, we get a final answer of 4.8 times 10 to the power of 5 joules. That will be our unit of measure for energy and work. So that gives us our first question. Then we can go and try question number 25. 25, a cannonball is fired with a speed of 88 meters per second from the top of a cliff. It strikes the plane below with a speed of 91 meters per second. If we neglect air friction, how high is the cliff? So we are looking at an energy system here. So as we know, we can start this equation. Since it's going from one set or one criteria of energy, a parameter of energy, to another parameter. In this case, let's say, for an example, we are going from kinetic to final. We are going from one state to another. However, not all of the energy of kinetic can be transferred to potential at all times. It could also be split between the two. Let me show you how. So we know that we have to start with an initial total energy, and it's conserved by an energy total final, because we're only using potential and kinetic energy in this situation. Considering that, we see that initially we have a speed that's introduced and we also have a certain height. So we can represent that as half mvi squared plus mg delta h. And we know finally we just have no height, but we do have a set speed final. If we were to rearrange this equation, we are going to be doing so for delta H, right? So if we are doing this for delta H, we know that the m's can essentially cancel out because they all factor out. Then we have half vi squared plus g delta H equals half vf squared. We are basically solving for delta H, so we need to bring all the terms to the other side. So we know we can do that. G delta H equals half vf squared minus half vi squared, and then we know as a result we can divide by g on both sides, and as a result we get delta H equals vf squared minus vi squared divided by 2g, because I factored out the half outside and then I basically put it in the denominator as 2 because it's essentially the same thing, right? Okay, so that is our height. So once we have that equation, it's all about plugging and checking. So we literally have delta H equals 91 meters per second square minus 88 meters per second square divided by 2 times 9.8 meters per second square. That's gravity or acceleration due to gravity.